So we're starting our new unit in our last unit, but this unit's not long at all. Some things you've learned, but this is ecology. First thing we're going to talk about ecology is ecosystems. So bio means life, and obviously you should know what sphere is. So biosphere is just a whole circle, which is going to be the whole world. Ecology is the interaction that takes place between an organism and their environment. Again, the biosphere is the portion of Earth that supports life. So every part of the Earth that has life. Abiotic is non-living. So this A cancels it out. So abiotic is non-living, and it influences organisms in the environment. So like temperature, moisture, light, soil. That's not living. It's just there to help us. Biotic, remember bio is life. Life here is you. It's all living organisms. Living things may depend on living off of others or other people's food. Populations. Population is a group of organisms of the same species who can have babies, interbreed, and live in the same area. They may compete for the same food. There's more than one frog at your house, and it may not be the same frog. They may not even be related, but they're the same species. They have to compete for food. Communities is a group of interacting populations. So this is more than one type of population. Some can affect the other population. Like, for instance, the hawks will eat mice, and then mice decrease, An ecosystem is made up of interactive populations in a community. So this is basically communities and communities of the abiotic and biotic factor. So this is the sun and the trees and the rabbits and the mice and the snakes and the hawks, all in one area. So the water. So we have the organism, then you have population, then you have communities, ecosystems, biosphere. You have to know this order. Biosphere, ecosystem, community, population, individual. Starts off with you, then there's a population, then there's a community, then there's an ecosystem, then the biosphere. So, flow of matter. What is the flow of matter? So this is when matter is consumed by an organism. It flows through levels of an ecosystem. It's pretty much cycle. It just keeps on going. Okay. Food chain shows how matter moves through the ecosystem. So quick, simple food chain. We have phytoplankton, who gets ate by zooplankton, who gets eaten by small fish. Those small fish get eaten by bigger fish, and then the bigger fish get eaten by the bigger ones like whales and mammals. Food web shows all possible relationships. In each level of the food pyramid, what's called the energy pyramid, it goes down by 10%. Producers are always at the bottom, and then we have everybody else that goes to the top. So, food chain, though, is everything. There's more than one thing that eats mice. There's more than one thing that eats grass. So, this is more realistic because it's a variety of everything. So, because of variety, that leads me to biodiversity. Biodiversity is a variety in the number of species in a specific area. Biodiversity increases closer to the equator and mountain areas. When you get closer to the equator, you have what they call rainforests, right? We see a lot of different things there. There's an importance, though, for biodiversity. Plants and algae produce oxygen and remove CO2, right? That is what we call photosynthesis. Humans depend on other organisms for food, right? Because we are not autotroph, we're heterotroph. Heterotroph means we have to kill something or eat something else to get energy. And a lot of times drugs and medicines is made by organic compounds, which is honestly made from a lot of types of plants. Exotic species. So exotic species is not native to that area. If it's very exotic, it's obviously definitely different, Can threaten the native species. Basically, it can be somebody who is, let's just say we had a giant. Giants don't live here like that. So if a giant came and he came to your house and tried to take over your house, you like, no, I lived here. Like, no, I've been living here for years, and you just pop up in town and try to take my house. That's what can happen with an exotic species. The value of biodiversity. If a species is removed from an ecosystem, it can have a drastic effect from the entire system. If we remove grass from a whole area, what's going to happen? Well, everything that ate that grass dies, right? So the grass gets eaten by, say, a ladybug, and then the ladybug gets eaten by a bird, and then the bird is eaten by a hawk. I'm just using this as an example, not showing this as a real thing. But if the grass is gone, then there's no more ladybugs, no more bird, no more hawk. Okay? Extinction. You should know what extinction is. Extinction is the disappearance of a species. Earth loses one species per year due to human activity. It's human faults. Believe it or not, 40% of all prescription drugs are made from some sort of living things. Humans will be affected if they go extinct. Really bad. So, ethical reasons. Many people believe that humans should be responsible for preserving biodiversity for ethical reasons. I mean, to an extent. I mean, we do need houses to stay, but do we really need 1,000 houses and we're only renting out 20? Or will we just rent out what is needed and not build that many? Many people believe that humans are responsible, so species and ecosystems have a right to exist, and they are valuable to nature. If we keep losing biodiversity, we lose the fascination and a reason to study the environment. But there is an issue that happens in population dynamics. Population growth. Look at this. This is too many people for me. Especially now with Corona. Nah, I pass, boo-boo. All organisms are members of populations. Populations die and grow at a steady rate based on the amount of resources available. So exponential growth, as you see, this is a curve. Population right here, initial increases organisms is slow, but once it starts producing, it goes a little bit faster. Population will increase due to the amount of reproduction. So the more we can reproduce, the more it will go, and it takes time. Obviously, we can't just pop 10 babies out at one time like a dog can. It takes us a while. It may take a woman 10 years to get pregnant, so it grows. And sometimes there's limitations, and this line right here is what we call the carrying capacity, which is here. Because sometimes the availability of food makes us get stuck. Diseases, predators, lack of space, and then birth exceeds deaths until it runs out. So what ends up happening here with this curve is if you're on an elevator and it says it holds 1,000 pounds, you got 3 people. It says 10 people or it says 1,000 pounds, right? But you got 3 people who weigh 350 pounds. That is 11. That elevator can actually break down, and you're looking like, no, it's only 3 people. But it said it can hold 10. No, it can only hold 1,000 pounds. Okay? Carrying capacity. The elevator will not function properly. So again, that cap line where everything pretty much stays the same, that is the carrying capacity. As you see here, it will go up and down. It's not always a perfect, but it will go up and down, but it will stay around that same. That is, again, the carrying capacity. So density. Density-dependent factors can increase with disease, predators, parasites, and competition for food. They affect the population, regardless of the has the volcanoes, the storms, the temperatures, and droughts. Human population. So demographics is the study of human population by size, density, distribution. This is U.S. census is taken every 10 years. So obviously, back in the day, we had about 1 billion people, but look at where they're thinking that we're going to have 10 billion people by 2050. I mean, that's y'all generation popping out children. Human population is growth during other organisms because humans have the ability to change their environment. Like, because we can find cures for diseases, right? We can find different ways to eat and do that. We can have clean water. Animals don't get the opportunity. We are pretty much the most intelligent animal creature on this earth. We have the ability to build what we want to build. We have the ability to cure what we want to cure. We have the ability. Animals just can't get up and say, you know what? Yeah, go eat from this tree and you'll live longer. They don't. They run out in front of a car and they die. Us, we have common sense and we look, oh, there's a car. Age structure, proportions of the populations are different in age groups. Okay. Um, if you look here in Mexico, it's pretty much equivalent. Ours, we have some areas, but you notice that there's more females when you get older. Okay. We do have more people. Uh, Mexico pretty much seems like once they hit about 40 something right here, life just kind of goes down. But for us, once we hit about 45 on down, you see the men drop dramatically. In the United States, it is proven that guys supposed to die earlier than females. Not probably because of the crazy things that they may do, but their bodies are just a little bit different. If you try to get life insurance, guys are way more expensive than females.